Another question I had was on number 5 from the card sort. So I went ahead and just, put the problem right here. And then I'm going to go ahead and take the derivative using the chain rule. So that would be 2/3 x squared minus 4 to the negative 1/3. And then the derivative of the inside is 2x. So there's the derivative in number 5. And again, before you do anything with your derivative, you want to have it as simplified as possible. There's nothing to factor here. You could technically factor this. I don't think that's a great idea because of the negative 1/3 exponent. Anytime you have negative exponents, you want to go ahead and put those in the denominator. Well, everything here is being multiplied together, so we can go ahead and just drop this to the denominator and keep everything else up top. So here's what my simplified derivative looks like. In my numerator, I have a 2, and then I have this 2x. And in my denominator, I have the 3 from the 2/3, and then I also have the x squared minus 4, and then it's going to be now to the positive 1/3 power. And we could simplify that just a little bit more, and you don't have to do this part, but the 2 times 2x is going to be 4x, and then in the denominator, we have 3 times x squared minus 4 to the 1/3 power. And then we're okay now to go ahead and determine our partition numbers. We're going to figure out where the derivative is equal to 0 and where the derivative is undefined. So the derivative is going to be 0 where the numerator of the fraction is 0. So our first partition number we get is at 0. And then I'm going to go ahead and figure out where the derivative is undefined by setting my denominator equal to 0. And remember, you're dividing by 3, but since it's 0 on the right-hand side, you're just going to keep getting 0. And what you technically do here is to get rid of a 1/3 exponent, you're going to cube both sides. But again, 0 cubed is just going to be 0. So you're just going to end up with x squared minus 4 equals 0, or x squared equals 4. And then just be careful when you take the square root, get plus or minus 2. So we actually have a partition number at 0, and we have a partition number at 2 and negative 2. So we're going to go ahead and make our number line. And I think probably the hardest part is going to be plugging these numbers into the derivative. So I'll kind of take my time on that part so that you understand it. And then let's see here. 0 made my derivative 0. And then negative 2 and positive 2 made my derivative undefined. So if I make my sign chart, again, we're focusing on the simplified derivative here. Let's do f prime of negative 3. Okay, so negative 3 times a positive 4 is a negative on top. And then on the bottom, we have this 3, but since it's positive, we can ignore it. And then if we plug negative 3 and we square it, we get 9. 9 minus 4 is a positive. And then the cube root of a positive is a positive. So we have a negative over a positive, which is a negative. Now let's do the next interval. Let's do the same thing for the derivative at negative 1. You plug in negative 1, negative 1 times 4 is a negative. And then here on the bottom, negative 1 squared is 1. And then 1 minus 4 is a negative, and the cube root of a negative is a negative. So now we have a negative over a negative, and that makes this interval positive. I'll kind of go here with this one. If we evaluate the derivative at 1 for the next interval, we get a positive over, this would be negative, and then the cube root of a negative is a negative, so that's going to be negative, and then the last interval is positive. And so I'll let you go ahead and finish it up, but the one thing I want you to check here is these 3 numbers are partition numbers because they made the derivative 0 or undefined. If you go back and look at the original is not a fraction. It's to the 2/3 power. You can take the cube root of a positive or a negative, and we're never going to divide by 0. So what you should notice is all 3 of these numbers, even though we figured out they were partition numbers, they're also critical values because none of them make the original undefined. So these all can be relative maxes or mins.